Okay, welcome back to this video clip. So in this video clip we are going to look at the KCSE structured questions, and before I look at that I would like to talk about NEC Mathematics Paper 1. So in Mathematics Paper 1 we normally have 70% of Form 1 work and Form 2. So the 70% of the paper covers Form 1 and Form 2 work, and then we have the 30% covering the Form 3 and the Form 4 topics. So once you're given the paper, what are you required as a candidate to do? So the first thing that you're supposed to do is that you're supposed to take at least 5 minutes just going through Section A and Section B. Then, after going through the paper, select at least 5 questions in Section B as you approximate the maximum marks that you can obtain within each and every question. Then highlight some of the 5 questions in Section B which you are so sure of, and these questions should be such that you can attain the maximum 10 marks or even below based on your ability. The time that is normally allocated for paper 1 is 2.5 hours. So as a student, what are some of the things that you're supposed to do? Allocate at least 1 hour for each of the two sections. That is, Section A, allocate 1 hour, Section B, allocate another 1 hour. Then the remaining 30 minutes you will be using it to check some of the questions that you are not too sure of as you are going through it. Then do not take more than 1 hour in each of the sections so as to be safe, because we normally have a tendency whereby students take more than 1 hour within one section and they end up not finishing the other section. Do not take more than 1 hour in each of the sections. Now, what are some of the requirements that you're supposed to have when you're handling this mathematics paper? 1, you should have a calculator, you should have a NEC approved mathematical table, a geometrical set, a long ruler, a rubber, and question paper. In Section B, there are some questions which are normally required to be done. So this question, each of them is normally allocated 10 marks. So I advise that you can start with any of the sections, but in most cases you'll always find that students who are weak normally start with Section B. So I'll go through Section B topics, and these are some of the topics that you are supposed to know before you go to Section B. The first topic is geometric construction. In geometric construction, you can construct triangles, you can construct trapezium, you can construct all sorts of equilateral figures, or not equilateral, but more so the 4 figures, and so on. And then we have scale drawing. In scale drawing, we have bearing, angles of elevation, depressions, survey techniques, and then the third one is gradient and equation of a straight line, followed by reflection and congruence, rotation, similarity and enlargement, area of common region between 2 intersecting circles, surface area and volume of solids, formations and solution of quadratic expression, statistic 1, angles and property of a circle, vector 1, commercial arithmetic, whereby in commercial arithmetic we have discounts, commissions, and so on. Then in Form 3, we have the quadratic graphs. We have solution of simultaneous equations using matrices, differentiations, and at times we may also have the loss-hiding set in paper 1, but not so common, and also vector 2 at times. And then another topic that sometimes they normally bring in Section B is area and approximation in paper 1. But the ones that I've just highlighted at the end are not commonly set in paper 1. So I'll be going through this topic, each and every topic. I'll start by looking at equation of a straight line. Equation of a straight line. So in equation of a straight line, that's the first topic that I'll focus on. Equation of a straight line. Equation of a straight line. Now, under equation of a straight line, you should be able to define what gradient is. Gradient. And this is the first part that I'm going to cover. How do we find gradient? So gradient, what's the definition of gradient? What is this thing we call gradient? So gradient simply means the slope of a line. So slope, the word slope here means gradient. Like for example, if you have a Cartesian plane of this nature, and within our Cartesian plane we have the y-axis and the x-axis. Then we can have several lines within this Cartesian plane. We can have a line that is moving such that the x-axis and the y-axis are equal. So this line here, let's name it line A. Therefore, it has what is called a positive gradient. Then we can also have another line that is moving downwards. This line has a negative gradient. And then we can as well have a line that is straight. We call it line C. This one has zero gradient. So we can also have a straight line here, like this. So if you find the gradient of this straight line, you find that this line D has no definite gradient. No definite gradient. So you find that you'll not be in a position to get the gradient. Okay, how do we now find the gradient? How do we find the gradient? So to find the gradient of a line, we need 2 points. We need 2 points. Since gradient is normally denoted by m, which is normally given as change in y over change in x. And suppose we have 2 points. Let's say point A is x1, y1, and point B x2, y2. Then to find the gradient between these 2 points on a line, then we go about it this way. So from m is equal to change in y over change in x, this implies that y2 minus y1, which is change in y, and then x2 minus x1, which is also change in x. And that's the formula that we can use to find gradient. So to illustrate this, to illustrate that formula, let's take a Cartesian plane in which we have the y-axis and the x-axis, and within this Cartesian plane we have a straight line with points A and point B, such that point A is x1, y1, and point B is x2, y2, such that the value of y at this point A, the value of x at this point A is x1, and the value of x at this point is x2. Then we'll have the value of y at this point as y2, and the value of y at this point is y1. So you can see this change in x, and also this one will be our change in y. So that the gradient will now be given by m is equal to change in y over this change in x. So this change in y over the change in x, which can also be gotten by simply getting y2 minus y1, y2 minus y1 all over x2 minus x1. And that's how we normally find the gradient of a line. Let's look at some of the examples. Example, find the gradient of a line. Find the gradient of a line. Find the gradient of a line joining points A 1, 3 and B, let's say 2, 8. So to find the gradient, from the formula we normally know that m is equal to change in y over change in x, which is always given by y2 minus y1 over x2 minus x1. Within these of our points, this one will be our x1, this one will be y1, then this one will be x2, and this one will be y2. So that our gradient will be 8 minus 3 all over 2 minus 1. So this one gives us 5 all over 1, which is 5. So the gradient of that line is 5. Then we can therefore summarize this. By saying that the equation of a straight line with gradient, and the gradient in this case can be given in form of m, and let's say and passes through points P in bracket xy and Q in bracket, so let's say this is x1 and y1, then this one x2, y2, so that the line passes through point P and Q, can be derived in the form. So we can form the equation of a line in this form. We know that from gradient is given by change in y over change in x, which is equal to y2 minus y1 over x2 minus x1. Then the equation can be expressed as, so we have three ways through which the equation of this line can be expressed. Now, the first way, we have point slope form. Point slope form. So the equation of that line can be expressed in form of point slope form. It can also be expressed, so in points and slope form, point slope form, we give an example of whereby we have y2 minus y1, which is equal to the gradient into bracket x2 minus x1. Then the second form through which the equation can also be expressed is number 2, which is slope intercept form. Slope intercept form, which is normally in the form of y is equal to mx plus c, which is very common. And then we have the third form, which is also common, which is called the general form. And in general form, we have ax plus by plus c is equal to 0. So that one, we refer to it as a general form. Examples. Let's look at the examples. When given 2 points, A is 1, 3, and B is maybe 2, 8, and I want us to find the equation of these lines. So we'll start by first of all finding the gradient. So from m is equal to change in y over change in x. So the gradient here will be 8 minus 3 all over 2 minus 1. This gives us 5 over 1, which is the same as 5. So once you get the gradient, you need only one point here to form the equation. So let's say we take point A as our 1, 3, and then maybe we assume that this point is not given. Let's give it as x and y, and then we have the gradient, which is 5. So we can go ahead and form the equation of that straight line by saying y minus 3 over x minus 1 gives us 5 all over 1. So when you cross multiply this, we will have y minus 3 is equal to 5x minus 5, which can also be written in the form of y is equal to mx plus c as y is equal to 5x. Then you bring this on this side, we'll have negative 5 plus 2, which is negative 5 plus 3, which is negative 2. So we'll have y is equal to 5x minus 2. So that one is what we refer to as the slope intercept form. Then we can as well express this equation in the general form. We can express that equation in general form. So the equation that we are having here is y is equal to 5x minus 2. So in general form, we will have negative 5x plus y, which is equivalent to negative 2, but now we can bring this negative 2 also this side. So when you bring 5x this side, becomes negative 5x. Bring this negative 2 this side, we'll have plus 2, which gives us 0. And this is the general form of that equation in the form of, this is the form in the form of ax plus by plus c is equal to 0. So what you should note here is that to form an equation of a line, you need at least 1 point and a gradient. So NB form equation of a line, you need at least one point and a gradient. You need at least 1 point and a gradient. So at times you may also be asked to work out some application questions. Like for example, let's look at a question that requires you to find a certain point. Let's say you are given a line with the following point, a line with points A is 3k and B is negative 2, 5. And maybe it has a gradient and has a gradient of negative 5 all over 2. So I want us to find the value of k. The value of k. Now how do you get the value of k? We start by writing the formula for finding gradient. We know that for us to get the gradient, which is m, you simply look at the change in y over change in x. Of course, our gradient in this case here is negative 5 all over 2, which is equivalent to 5 minus k all over negative 2 minus 3. So this one, if you work out, you'll get negative 5 all over 2 is equal to 5 minus k all over 5, negative 5, negative 2 minus 3 is negative 5. If you cross multiply this, you'll get 2 into bracket 5 minus k is equal to negative 5 times negative 5. Of course, this one gives us 10 minus 2k is equal to 25. Then we'll have negative 2k is equal to, take this 10 this other side, it becomes 25 minus 10, which is 15. Then divide both sides by negative 2, so our k will be 15 divided by negative 2. So this one gives us k as negative 7.5 or negative 7.5. So it means that the value of k there will be 7.5. 7.5. Then the next thing that I also want us to look at is getting the y-intercept and the x-intercept. The y-intercept and the x-intercept. And x-intercept. So at times you may be required to find the x and the y-intercept within an equation. So there's something that you need to know here. You need to note that at y-intercept, always x is always 0, and also at x-intercept, y is also equal to 0. And if a line passes through, another point is that if a line passes through, the points, A0 and also 0, B, then A and B are called so A here is on the X, so X intercept, and B here is on the Y, we call it Y intercept, respectively. So the equation of this line can be written as, so the equation, we can simplify it and write it in the form of x over a plus y over b is equal to 1. So whenever an equation of a line is written in this form, just know that the value of a gives us the x-intercept, and at the same time the value of b gives us the y-intercept. For example, in the previous equation that we had looked at, so in our previous equation, we got the equation of a straight line of this form, y is equal to 5x minus 2. So if we are to find the x and the y-intercept in this equation, we'll first of all write this equation in the form of x over a plus y over b is equal to 1. Okay, so if you want to write it in this form, what we need to do, first of all, we can bring this x this side so as to have negative 5x plus y is equal to negative 2. Then make this 1. How do we make this one 1? I can decide to divide everything here by negative 2, negative 2, negative 2, so as to have this and this will go 5 all over 2x plus y all over negative 2 is equal to 1. So you can see this one is 1, this one is y over negative 2, which is the same as b. But now this one I want to write it so that I can only have x on the upper side. So for me to get this, it means I have to divide this x with 2 over 5 to get 5 over 2x. So this one can be written as x all over 2 over 5 plus y all over negative 2 is equivalent to 1. So what does this one tell us? This one tells us that the x-intercept is equal to 2 over 5 and y-intercept is negative 2. The y-intercept is negative 2. Of course, there are so many ways through which you can find the intercept, apart from writing it in this form. We can also say that at x-intercept, y is equal to 0. So if you set y to be 0, at x-intercept we'll have 0 is equal to 5x minus 2, which is the same as you bring this to this side, we'll have negative 2, this side becomes positive 2 is equal to 5x, divide both sides by 5. So our x will be 2 over 5. So it means that 2 over 5 will be our x-intercept. And then at y-intercept, we have x is equal to 0. So you set x to be 0 within our equation here. So our equation is y is equal to 5x minus 2. So if you set x to be 0 here, we'll have y is equal to 5 times 0 minus 2. So y will be negative 2. So our y-intercept here will be negative 2. Okay, two lines are perpendicular. So two lines are perpendicular, and the symbol for perpendicular is that if the product of their gradient, is -1. So whenever you have the product of the gradient of two lines, you always get -1. That is, if let's say the first line has a gradient of m1, and then you multiply with the gradient of the second line, which is m2, you should always get -1. E.g., if you have these two lines, let line 1 be y is equal to half minus a quarter x, and line 2 be of the form y is equal to 4x plus 2. So when you look at these two lines, the coefficient of x, which is always the gradient, at this point is -1/4, and then the coefficient of x this side is 4. So if you multiply these two gradients, you will find that -1/4 multiplied by 4 gives us -1. So this one means that whenever we have two lines that are perpendicular, they will always give you the product of their gradient as -1. Hence, the lines are perpendicular. Hence, the lines are perpendicular. So let's look at examples. Examples for the perpendicular lines. So for the example, I'll look at two examples. Let's look at example 1. In example 1, we have a straight line through the points A, which is 2, 1, and B is 4m, is perpendicular to the line whose equation is 3y is equal to 5 minus 2x. Determine the value of m and the equation of the line AB. So we have a straight line that is passing through points A and B, and at the same time it is perpendicular to the line whose equation is 3y is equal to 5 minus 2x. Then I want us to look for the value of m and then the equation of the line AB. So first of all, we can get the gradient of this line AB from this equation. So we can first of all obtain the gradient at this point by writing this equation in the form of y is equal to mx plus c. Then we shall have got the gradient for this line. And then since we know that the product of the two gradients should give us -1, we can get the gradient of the line AB. So solution to this, you can do it at the top here. The solution. So the equation that it is perpendicular to is 3y is equal to 5 minus 2x. Let's write it in the form of y is equal to mx plus c. We can divide both sides by 3 so as to have y is equal to 5 all over 3 minus 2 all over 3x, which I can write in the form of y is equal to mx plus c. Y is equal to negative 2 over 3x plus 5 all over 3. This one implies that m1 is equal to negative 2 all over 3. Now if m1 is negative 2 all over 3, and then we know that m1 times m2 should give us negative 1. So this one implies that our m2 will be negative 2 all over 3 times m2 is equal to negative 1, which means that m2 will be 3 all over 2. So we'll have the gradient of this line as 3 all over 2. Then I want us to get the value of m. The value of m. I want us to get the value of m. So we are supposed to get the value of m from the equation. Determine the value of m and the equation of the line. So from the points that we are given A as 2, 1 and B as 4m. And the gradient we have got m2 to be 3 all over 2. So I can go ahead and get the value of m. From m is given by change in y over change in x. Therefore, our m2, which is 3 all over 2, is equal to m minus 1 all over 4 minus 2, which will give me 3 all over 2 is equal to m minus 1 all over 4 minus 2 is 2. We can go ahead and cross multiply this, we get 6 is equal to 2m minus 2. So that we bring this to this side, we have 2 plus 6, which is 8, is equal to 2m, divide both sides by 2, we get m to be 4. So the value of m is 4. Now that we have those two, we have the 2 point, we have the gradient, we can go ahead and get even the equation of the line. So equation of line AB will now be, so since I have 1 point, I can take point 2, 1, and maybe another point which is xy, and I have the gradient which is 3 all over 2. I can go ahead and get the equation. So my equation will be y minus 1 all over x minus 2 is equal to 3 all over 2. Of course, if you cross multiply this, we'll get 2y minus 2 is equal to 3x minus 6. So that 2y is equal to 3x. Okay, bring this side, we get negative 4. This one is negative 4, divide both sides by 2. So this one implies y is equal to 3 all over 2x minus 2. So our equation will be y is equal to 3 over 2x minus 2. Then the next example, that I also want us to look at, example 2. So I want us to look at example 2, and example 2 reads a line example 2 reads a line has an equation line has an equation as y is equal to 4x plus 3. Find the equation of the second line perpendicular to it. And passes through passes through 1, 2, and passes through 1, 2. Give the answer in the form of ax plus by plus c is equal to 0, which I had previously said to be the general form, and state the constants a, b, and c. So we're supposed to give our equation in this form, and at the same time we state the constants. So we have a line whose equation is y is equal to 4x plus 3. And then we are supposed to find the equation of a second line that is perpendicular to it, and this line is passing through 1, 2. So the solution to this is that from this line here, we have y is equal to 4x plus 3, which has been written in the form of y is equal to mx plus c. So our first gradient here, we can just pick it directly as 4, so that we can get the gradient of the line which is perpendicular. So we are supposed to find the equation of the second line that is perpendicular to it and is passing through this point. So we have 1 point. Let's get the other gradient. So from m1 times m2 is equal to -1, we have 4m2 is equal to -1, so that m2 will be -1 all over 4. Therefore, we have the gradient of m2 as -1 all over 4. And we also have another point which is 1, 2. So you can go ahead and form the equation. So the equation here will be y minus 2 all over x minus 1 is equal to -1 all over 4. So that if you cross multiply this, we'll have 4 into y minus 2 is equal to -1 into x minus 1. Of course, this one will give us 4y minus 8 is equal to -x plus 1, which if we work out that, we will have, so we have this as 4y minus 8 is equal to -x plus 1. So this one, if we bring all of them this side, we'll have x plus 4y minus 8 minus 1 is equal to 0. So x plus 4y minus 9 is equal to 0. So that one becomes our general formula that we were looking for. So the next thing that I want us to look at are parallel lines. Parallel lines. So we have parallel lines. Under parallel lines, you can say that two lines are said to be parallel. Two lines are said to be parallel if they have the same gradient. If they have the same gradient, i.e. m1 is equal to m2, that is the gradient. E.g., let's look at an example. Let's say we have two lines which are of the form y is equal to half x plus 7, and another line y is equal to half x, y is equal to half x minus 20. So these two lines, they have got the same gradient. The reason why they have got the same gradient is because m1 is equal to m2, and the gradient here in these ones are a half. Therefore, they are parallel. Hence, they are parallel lines. Obtaining coordinates of midpoint. So let's say you have 2 points. So let points A where and B be x2, y2 be the endpoints, of line AB. To obtain the midpoint, we have so this is the line, and within the line we have point A, which is x1, y1, and then B, which is x2, y2. And I like to get the midpoint M at that point. So for us to get that midpoint, then the formula that we're going to use will be x1 plus x2 all over 2, comma y1 plus y2 all over 2. So this one will give you the coordinate for the midpoint. So let's look at an example. Another example, let's say A is 2, 4, and B is 4, 6. So if you are given those 2 points within a line, and you want to obtain the midpoint of line AB, then the solution will be, so from the formula, we'll say 2 plus 4 divided by 2, comma 4 plus 6 divided by 2. Of course, this one gives us 6, which if you divide by 2, you get 3. This one gives us 10, you divide by 2, you get 5. So our midpoint will be 3, 5 as the coordinate. Then another example. Another example to this, maybe we can also have another point, like let's say if you have point P as 1, 2, and Q as 3, 4. So we can find the perpendicular bisector, the point at which the line, the point within the midpoint of the line. So we simply have 1 plus 3 divided by 2, and then 2 plus 4 divided by 2. So this one give us 2, 3, which will give us the midpoint. Points of intersection. Points of intersection of two lines. Points of intersection of two lines. Then we can note that to find the point the points of intersection of two lines then you simply solve the two equations of the line, simultaneously. So simply solve the two lines simultaneously. This simultaneously means you can either solve by elimination method or substitution method. Elimination method or substitution method. Like, let's say if you want to find the point of intersection of two lines, let's say we have L1 as y is equal to 4x plus 12 and L2 as y is equal to 5x plus 36. Now if I use the substitution method, of course this one is y and this also y. So if this is giving us this as y, this is also giving us this as y. If you use the substitution method, it means that this one is equal to this, because at these 2 points, those lines are going to meet at the same point of y and at the same point of x. So I'll simply say that this is equal to that, then I solve for x. So 4x, solution to this will be 4x plus 12 is the same as 5x plus 36. So that if I bring this one this side, I'll have 4x minus 5x is equal to 36 minus 12. Taking this one this side, get 12. So this one will be negative x is equal to 24. Divide both sides by -1, so x will be negative 24. Now if x is negative 24, I can go ahead and get the value of y by substituting this x in any of these two equations. So I can use maybe the first line so as to have y is equal to 4x plus 12, then inject this negative 24 where we have x, will have y is equal to 4 into negative 24 plus 12. So this one gives me y as 84. So that is this time this, then like that. So our y will be negative 84. So the point of intersection will be negative 24, negative 84 as our point of intersection. So thank you for listening to me during this lecture. And what we are now remaining with in this equation of a straight line is the angle between the lines and the x-axis, and also the angle between two lines. And then we'll also look at some numerical problems that are involved when calculating equation of a straight line. Otherwise, thank you.